Here we have the integral of cotangent to the 6 of x. Let u be cotangent of x. And then square both sides. We get u squared is equal to cotangent of x squared. Add 1, we get u squared plus 1 is equal to cotangent of x squared plus 1. From trigonometry, identities, cotangent squared of x plus 1 is cosecant squared of x. U is cotangent of x. The derivative of u with respect to x is negative cosecant of x squared. Du will be negative cosecant of x squared dx. But cosecant of x squared is u squared plus 1. Multiply both sides by negative 1 over u squared plus 1. Then we get this equal to dx. The integral of cotangent of x to the 6 now becomes u to the 6 since u is cotangent of x. Dx is negative 1 over u squared plus 1. Now we get negative times the negative and then the integral of u to the 6 dividing by u squared plus 1. Since this is the 6 and this is the second, so what we can do is go ahead and use polynomial long division and divide u to the 6 by u squared plus 1. And in setting up the long division, we can rewrite the denominator as this u squared plus 0 u and then plus 1 and then divide. And we'll end up with u to the 4th minus u squared plus 1 minus 1 over u squared plus 1. And now the integral of tangent of x to the 6 will be negative u to the 6 over u squared plus 1, which is negative integral of u to the 4th minus u to the 2nd plus 1 minus 1 over u squared plus 1. Antiderivative of u to the 4th will be u to the 5th dividing by 5, and then antiderivative of u to the 2nd is u to the 3rd, and then antiderivative of 1 is 1u, and then minus the integral (1 over u squared plus 1 du. So here we have a minus and minus, so that will become plus. This will be negative u to the fifth divided by 5, dividing by 5, and then minus, negative, and then negative, we get positive u to the third divided by 3, and here we get minus u. And this is minus and negative, so that's why this becomes plus. And now let's find this integral, the integral of 1 over u squared plus 1. This has the form of 1 over u squared plus a squared, and so we can use the tangent inverse formula for that. Recall that the derivative of tangent inverse of x over a is a over a squared plus x squared. And so we end up, and so this is how we get this formula. The integral of 1 over a squared is 1 over a tangent inverse of x over a. Here we have the integral of 1 over u squared plus 1. So we can let a squared be 1. So let a squared be 1. And then take the square root of both sides, then a is 1. And so the integral of 1 over u squared plus 1 is equal to 1 over a times tangent inverse of u over a. The variable here is u, so that's why we have to put u. The variable here is x, and so we put x. But a is just 1, so we end up with tangent inverse of u. So the integral of 1 over u squared plus 1 is tangent inverse of u. And so back to the integral here. So this integral is equal to tangent inverse of u. But u was cotangent of x. And so u, we get cotangent of x, and then here we get the last term here is tangent inverse of cotangent of x. And this is the answer.